Proving congruence, SSS, side, side, side. Book 1, Proposition 8. If two triangles have the two sides equal to two sides respectively and also have the base equal to the base, then they also have the angles equal which are contained by the equal straight lines. In this unit, the congruence of triangles will be the focus. The modern version of Euclid's Proposition 8, above, is the side, side, side postulate, which is typically shortened to the SSS postulate. The SSS postulate states if three sides of one triangle are congruent to three sides of a second triangle, then the triangles are congruent. Here's the postulate in action. Given that AB equals DE, AC equals DF, and BC equals EF, prove that these two triangles are congruent. Alright, so we start with the given statements. So we see because they're equal, they're also congruent to each other because that's the definition of congruent segments. Therefore, the two triangles are congruent because of the SSS postulate. SSS is a postulate because Euclid had no way to prove it. Like all postulates, we accept the statement without proof. Of course, if someone had come up with a counterexample to disprove it, then the postulate would have been abandoned long ago. But alas, the SSS postulate has stood the test of time, as no one in thousands of years has found the statement to be false. Okay, so here's a two-column proof puzzle. Given that AF equals GB, so this segment equals this segment, and AK equals BK, prove that these two triangles, the yellow one and the blue one, are congruent. Alright, so we begin with what we're given, and then we have that these segments are congruent, and that is the definition of congruent segments. And we also know that this triangle in the middle here, the white triangle, is equilateral triangle, and that's also given. Alright, and then we know that these two segments here and here are equal because that's the definition of an equilateral triangle, equal sides. Therefore, these two triangles are congruent due to the SSS postulate. Here's another two-column proof puzzle. Here we are given that FG equals JK and FH equals HJ. That's given. Because that is true, we know that those segments are all congruent because that's the definition of congruent segments. The other piece of given information is that H is the midpoint of this line here, GK, and that's given. So we know that these two segments, GH and HK, are congruent because that's the definition of a midpoint. That makes these two equal. Therefore, we have these two triangles are congruent due to the SSS postulate.